All right, welcome back to the Unit 4A practice test video series with sound. Okay, so we're just going to jump right in. We'll start on the simplifying radicals problems. All right, so starting with number 7. The big thing I want you to see here is it does not say multiply the expressions or find the product of the expressions. It's saying show how, which means I need to see the work. I don't want to just see a number. I need to see how you figure this out, not what the numerical answer is. I know that sounds nitpicky, but if you are taking the EOC, and this has happened before and it made me cry, if you're taking the EOC and the EOC says, explain how to solve this problem, and you just say the answer is 5, it's 100% wrong, no points, no partial credit, because you did not answer the actual question, which was explain how or show how. So 7 says show how each of these expressions will result in a rational product. So we're taking the square root of 2, we're multiplying it by each of these expressions, and it should result in a rational product. So let's look at this. So we know that square root of 2, square root of 8, square root of 32, and a second square root of 2 are all irrational numbers. So I'm going to put that to the side because that's important. So all of these numbers are irrational. Okay, so we're going to simplify, or we're going to multiply and see if we can get a rational product. So square root of 8 times square root of 2. So look at it. It does say square root of 2 times, and then we're multiplying square root of 2 by all of these. So square root of 8 times square root of 2. If I multiply that, I get square root of 16. Well, what is the square root of 16? That's actually a perfect square. So when you take the square root, you're going to get 4, which is a rational number. I multiplied two irrational numbers and got a rational number. Okay, so square root of 32 times square root 2. 32 times 2 is 64. Okay, so the square root of 64 is 8. Again, two irrational numbers multiplied together gave me a rational number. Okay, square root of 2 times square root of 2. This is my favorite. Okay, square root of 2 times square root of 2 is square root of 4, which is what? 2. When you take a irrational number times itself, or any, well, I mean, yeah, if you take the square root of something times itself, it undoes the square root, because square root literally means what something times itself to give you this number. So if you take the square root of 2 times the square root of 2, well, 2 times 2 is 2 times itself, so it cancels itself out, and you're left with just 2. Okay, so if you noticed, all of the numbers were irrational. So an irrational times an irrational can give you a rational number. Notice none of these were rational. In fact, if I take a rational number, so let's do square root of 4 times square root 2. Okay, so the square root of 4, I can take the square root of 4 and get 2. So that gives me 2 times the square root of 2, which is irrational. It's not rational. Okay, well, what if I did it the other way around? What if I did 4 times 2 and got square root of 8? Okay, well, that's still irrational because you can't take the square root of 8. These two things are equivalent, by the way. They're both going to be irrational. So an irrational times a rational number will not give you a rational number. So you can only multiply two irrationals to get a rational number. And just for further clarification, not every irrational number is going to work. Let's say I did square root 2 times square root 3. That's going to give me square root 6, which is also irrational. So it's still two irrational numbers giving me an irrational. You can multiply an irrational number by some irrational numbers to get a rational number. So it doesn't always equal rational, but can sometimes be rational. I know some of you are thinking, okay, she's off on a tangent again. No, this is actually probably the most important thing you can get from this. Irrational times irrational can be rational. Won't always be, but it can be. Not every time, but sometimes. However, if you do a rational number times an irrational, it will always be irrational. There's no way to make it rational. Okay, number 8. Same kind of question. We're going to show that all of these sums are going to be a rational number. So I've got square root of 36 plus something. Now here's something that's important. Square root of 36, is it rational or irrational? It's got a square root. But square root of 36 is 6. That's why this is rational. Okay? So let's look at all of these numbers and see if they're rational or irrational. Square root of 81. Can you take the square root of 81? You can. It's 9. 7 is 7. Square root of 36 is 6. All of these are rational. Okay, so all of these numbers are rational. All right, so square root of 81 plus the square root of 36, that's 9 plus 6 is 15. Yes, that's rational. 7 plus 6 is 13. Yes, it's rational. 6 plus 6 is 12. Yes, it's rational. A rational plus a rational will always be rational. Rational plus rational is always rational. Okay? An irrational plus anything, rational or irrational, it will always be irrational. An irrational plus anything will end up being irrational. Two rationals together will always be rational. Okay. And then the next problem, number 9, is a division problem. The same rules that we had for multiplication apply for division. In order to make a number rational, if you have an irrational number and you want to divide it to get a rational number, you have to divide it by another specific irrational number. Okay. All right. So number 9, same process. Okay, we have 15 over the square, or I'm sorry, 15 times the square root of 48 over over any of these expressions. This box should really be kind of like under this fraction bar, but we're basically taking this and dividing it by all of these and seeing if it's rational or irrational. So square root of 48, we cannot take square root of 48, so this one is irrational. Square root of 12, square root of 3, square root of 48. All three of these, if you put in the calculator and double check me, you're not going to get anything pretty. It's going to be irrational. So remember, we already said irrational divided by irrational can yield a rational number. If these were rational and we had our irrational number, we still would end up with an irrational number. Whew, okay. Sorry. All right, so I have irrational. There we go. All right, so I'm going to take this term and divide it by all three of these. So we'll do 15 square root 48 divided by square root 12. 48 divided by 12 is 4. So this is 15 times the square root of 4. The square root of 4 is 2. And 2 times 15 is 30. Here, I'll put this down here just in case we need it. Okay, we're going to do divided by 3. So I have 15 square root 48 divided by square root 3. 48 divided by 3 is 16. So this is 15 times the square root of 16. Square root of 16 is 4. So 15 times 4. If you own a clock, you know, if you own an analog clock, not a digital clock, you know that 15 times 4 is 60. Actually, you might know that with a digital clock. You know there's 4 15-minute sets in an hour. In an hour, 60 minutes. I don't know. Okay. Hopefully y'all knew that. That's how I know my 15s. All right. All right, so we have 15 square root 48 over 5 square root 48. All right, so I'm going to divide. I'm going to do 15 divided by 5 first, and that is 3. Square root 48 divided by square root 48 is square root of 1. The square root of 1, I hope you know, is 1, because 1 times 1 is 1. So we've got 3 times 1, which is just 3. All 3 of these quotients are rational. We divided an irrational number by another irrational number and got a rational number. Now, remember, there are some irrational numbers. If you divide them by another irrational number, it will end up irrational. But if you do this right and you divide by something that you know is going to give you a perfect square, you can take 2 irrational numbers, divide them, get a rational. All right, let's move on to just some math with square roots. Let's go on to number 10. It says simplify this. If necessary, leave your answer in simplest radical form. When it says this, that means that do not give us a decimal. It's a pain in the butt. Nobody likes decimals. Leave it as a radical. Do not take it and put it into, like, don't put it in the calculator and get a decimal. If you put it in the calculator and do a decimal, you didn't have to do any math. So why would I bother teaching you this? Okay, so when we add or subtract radicals, you can only add or subtract like radicals. It's just like doing like terms like we've done for years. You can't add 2x plus 3y. They don't have the same variable. When we do radicals, you can't add k or square root k to square root m. They're not like radicals. You can't add the square root of 3 to the square root of 7. They're not like radicals. They have to have the same index and same radicand. So, yeah, so let's start for there. So the radicals we can combine. We can combine 2 square root k and just square root k. If I add these together, it's going to be 3 square root k. I've had a lot of people ask me, well, how do I know that that's just 1 square root k? Well, if it were 0 square root k, it wouldn't be there. If it were 2 square root k, it'd have a 2 there. So the only logical, if it were any other number, the number would be there. And if it were 0, there wouldn't be anything there. Because 0 times anything is 0, and what's the point of writing it? So we have just this square root k by itself. So what I tell people, it's like if you go to the store. If I tell you, I went to the store yesterday and I bought an apple. How many apples did I buy? Did I tell you specifically that I bought 1 apple? No, but you knew I only bought 1 because I said I bought an apple. I didn't say I bought 4 apples. If I bought 4 apples, I would have told you I bought 4. I just said I bought an apple. That implies there's only 1, even though I didn't specifically say 1. It's the exact same thing with a radical or with a like term or with a variable. If there's not a number there, you can assume that there's 1 of them. So I have 2 square roots k plus another square root k, so that would be 3 square root k. Here I have negative 4 square root m plus 5 square root m. So I'm going to add the coefficients. Negative 4 plus 5 is positive 1. So I've got 1 square root m. Again, we don't have to write the 1 there. We just know we have a square root m. So we're going to leave it as square root m. And that's as simplified as it can get. I can't combine those 2 radicals. I can't simplify those 2 radicals. We're going to leave it there. Okay, number 11. This is a multiplication problem. So we're going to multiply these 2 radicals. You're going to multiply the coefficients first. So you're going to do 2 times 5. which is 10. And then we're going to take the square root of whatever we multiply. Okay, I'm sorry. We're going to multiply our radicands next. So 10 times 40 is 400. And then I can simplify this. So we're going to see if you can simplify. If you can't simplify, you would leave it here. But I can simplify the square root of 400. Something times itself gives me 400. If you you can do that in the calculator, but or you could simplify with a factor tree, or you can just trust me that 20 times 20 gives me 400. So the square root of 400 is 20. Okay, so we have 10 times 20. If I multiply those, that's 200. Number 12, I want to simplify the square root of 54 over the square root of 2. So this is just a division problem. I'm going to divide if possible, or well, it is possible. I'm going to divide it and then simplify it if possible. So square root 54 over square root 2. I can take the square root of whatever 54 divided by 2 is. And when I divide that, I should get 27. A lot of people in the first quiz just gave me something like 27 as the answer, but you haven't taken the square root yet, so don't get rid of the square root. All right, so I can't take the square root of 27. If I didn't know how to simplify it further, I could leave it here. However, I am going to show you real quick how to simplify it further. I'm going to give you my dumb story for it too. So very first thing you want to do, I want you to remember square root means something times itself gives me this number. If I want the square root of 27, I want to know what times itself gives me 27. So there is no whole number times itself that will give me 27. But I can split this down into a bunch of numbers, into all the prime factors, and then I can find the things that do multiply times itself. So to get 27, I'm going to think of two numbers that I can multiply to get 27. And the only thing I can think of is 9 times 3. Well, I can think of 27 times 1, but if you're going to do something times 1, you're going to be in this infinite loop that doesn't end. So do not split into one-time stuff. You're going to have it's a pain. Don't do it. All right, so we've got 27 broken into 9 and 3. Okay, I don't want to confuse myself. 27, instead of 27, we have 9 times 3. I don't want to use that anymore, so I'm crossing it out so I don't confuse myself. Okay, 9, I can split into 3 times 3. Okay, so in order to get 27, I can do 3 times 3 times 3. Okay, 3 times 3 times 3. That would give me 27. All right, so these are the things that multiply to give me 27. If I multiply all three of these numbers, I get 27. So I want things times itself. Well, here I have a 3 times itself, right? I have a 3 and a 3. So I know I can do 3 times 3. It won't give me 27, but 3 times 3 times something else will. So I could take these two 3's outside of the radical. And on the inside, I would leave this little single 3 that's by itself. And that would stay inside the radical. So this is a 3 times a 3. So when I take the square root, I've got a set of things that multiply with itself that come out and are outside the radical, and then something that doesn't have a partner to multiply with stays in the radical. Okay, so that's the mathy explanation. If you want kind of a dumb way to remember it, because sometimes our brains love little dumb stories to remember stuff. Okay, so after you break your radical part, I like to tell people that it's prom night. And prom night, you know, it's fun. You've got things like Cupid Shuffle and Cha-Cha Slide to dance to, but then they play the slow jam. And if you hear the slow jam, you don't go out on that dance floor unless you have a date. Sorry, that's just how slow jams work. So, you've got couples. You've got a pair of dance partners. They're going to come out and they're going to dance on the dance floor, and it's going to be sweet and romantic. They are one couple. They come out as one couple onto the dance floor. And then your singles, your little nerds that don't really have anybody to dance with, and no shade towards nerds, that was me, Hashtag true story. Your nerds are going to stay on the bleachers and sit and watch everybody else. So that's where your nerds and your single people go. Sometimes they sit in the bleachers next to their math teacher. Or, yeah, hashtag true story. No judgment. I didn't have a date to prom, and that's okay. I turned out okay. I'm only a little twitchy. So, anyway, your partners, your pairs, which you can take the square root of, comes out of the square root, and then your single factors that don't have a partner stay on the inside. So this is the simplest radical form. If you look at it, we had a 9. 9 is a perfect square. We broke it apart. We took the square root of that. That's 3. It came out here. So your things that are perfect squares are broken down and pulled out here. So this is a more simplified version of this. These are equivalent. This is just the simplified version. Okay. So number 13. All right, number 13. We are going to simplify this big old Bertha of an expression. It's got some multiplying, it's got some dividing, it's got some variables, it's a lot of fun. So, and we're going to simplify it as far down as we can. All right, first thing I would want to do is let's take care of numbers. We have a 9 divided by 3, which is 3. That's an easy problem. We can take care of that. That's one less thing we got to worry about. Then let's worry about the stuff in the radical. We have a 45 divided by 5. 45 divided by 5 is 9. Okay? And then we have this m squared. So this is everything that's still in the radical. Here's the beauty. We canceled out the 3. We canceled out the square root 5. We don't have a fraction anymore. Boom. That's taken care of. So now we just have 3 square root 9, or 3 times the square root of 9m squared. All right, square root. Let's see if we can take the square root of anything. So square root of 9, we know is 3. Square root of m squared is m. Okay? If you didn't know that, just remember, if you take the square root of anything that's squared, those are inverses. Those cancel out. So the square root of something squared cancels. If you just struggle with variables in general, you could go back to that splitting method. M squared, that means there's 2 m's, right? M times m. Well, there's a partner, there's a Dance couple, they come out of the radical, and look, there's nothing left in the radical, so the radical goes bye-bye. All right, so we have 3 times 3 times m, which is equivalent to 9m, and there's my answer. All right, number 14, simplify the square root of 5/7. If necessary, leave your answer in simplest radical form. All right, so looking at this, I can't divide 5 by 7. It's not because that's as simple as it's going to get. So why don't we split the radical in 2? Let's have square root of 5 divided by square root 7. Okay. I know I've told you before, there is not okay to have a radical in the denominator of your fraction. If I gave you a chocolate bar, especially a Hershey's, where it's already pre-marked, you don't have to do any hard math. If I gave you a Hershey bar, and I told you to divide that into 3 pieces, you could do it. You could break it apart, divide it in 3 equal amounts. Pretty close to, anyway. If I gave you that Hershey bar and told you to divide it into the square root of 3 pieces, that to me does not make any sense. It's going to be hard to do. It's an irrational number. You can't really divide by an irrational number and it come out nice and pretty and even. It does not make sense. So, yeah, just off the top of the head, can't divide something into square root pieces. All right, can't do it. So we have here, we don't want a denominator to have a square root. So what we're going to do is we're going to multiply this whole thing by something that would make the bottom rational. So what is something that I can take the square root of? I want a perfect square that 7 will go into. And the only one I can think of is square root 49. So we have to figure out a way to get there. Here's a trick. If you can't think of anything to multiply by to make something rational, a square root times itself will cancel the square root. Because what you're doing is the square root of a times the square root of a is the square root of a squared. And remember, the square root and squared cancel out, so you're just left with a. All right? So to put that with numbers, if I want to cancel out the square root, I can do the square root of 7 times the square root of 7. That will give me the square root of 49, which is 7. The square roots will just basically cancel. Remember, if you multiply the denominator by a number, you have to multiply the numerator by that same number. Because technically, the square root of 7 divided by the square root of 7 is 1. So you're really not multiplying it by anything. So you're not changing the number. You're just multiplying it by something to make it a prettier version of itself. So we're going to multiply. 5 times 7 is square root 35. Square root 7 times square root 7 is square root 49, which is 7. Square root of 35 can't be broken down. And we're just going to leave it here. Okay. All right, this video is getting a little long, so I'm going to do 15. That's our last radical problem. And, let me adjust. 15 is our last radical problem, so I'll do this one, and then I'll do a part 3, and that will be our last video for this practice test. So, we have a rectangle. The area is 20 m cubed times the square root of 15. And then my width is 5m times the square root of 6m. And I don't know my length. Okay, so how do you find area is the first question. Area is found by doing length times width. You multiply length and width to get your area. I don't know my length, but I do know my width and my area, so I can plug those in. Now, I know a lot of people don't like a lot of variables, so why don't we get length by itself here, and then we'll plug in. So how would you get the length by itself? Well, you would divide by the width. So those cancel, so your length is equal to your area divided by your width. So my area is 20 m cubed times the square root of 15. And my width is 5m times the square root of 6m. Okay, so we're going to simplify piece by piece. 20 divided by 5 is 4. M to the third over m. Remember, there's an invisible 1 by that m. You subtract your exponents. That becomes m to the second. And then as far as my square root goes, I can't simplify 15 and 6m. So what I think I'm going to do... Ooh, actually, I lied. I can divide 15 and 6 both by 3. So 15 divided by 3 is 5. And then on bottom, 6 divided by 3 is 2, and I'm still left with that m. That looks a lot better. That looks a lot easier to work with than where I was going with it originally. Okay, so I have a radical on the bottom. Can't do that. So to cancel that out, you gotta multiply it by something that would make it rational. Now here, because we have a variable, the only thing I would do, I would just multiply by the radical itself. So we're going to multiply the numerator and denominator by the square root of 2m. Okay, so what happens on top, we have just that 4m squared still, times the square root of 5 times 2 is 10, so we've got square root of 10m, over square root of 2m times square root of 2m. The square roots will cancel themselves out, and we'll just be left with 2m. Okay, and then to simplify this and make this a little bit prettier, we can divide again. So 4 divided by 2 is 2. M squared divided by m is m. And we have times the square root of 10m. And I'm going to leave that here. And we're all done. Yay! Okay. And this is the length of my rectangle, if we forgot. All right. So, I'm going to leave this here. We're going to stop it here. There will be a part 3 that will finish this whole quiz, or this whole practice test up. Hope you are getting some good study time in. Don't wear yourself out. Like, take breaks when you need to. Make sure you get a good night's sleep, all that good stuff. But I hope this is helpful. Have a good evening. Be on the lookout for part 3.